Welcome to the deep dive. Today we're plunging into a really fascinating corner of AI. We're talking about reward models. Now, these are surprisingly central to how powerful language models behave, yet they've largely remained in the shadows. These are the critical bits supposed to align AI with human values, but as we'll find out today, they're still very much a black box. So our mission for this deep dive is to finally peek inside these hidden mechanisms. We want to reveal unexpected biases and, frankly, some strange patterns in how they actually interpret what we think of as human values.
That's right. At their core, reward models are basically specialized neural networks. Their job. Take text, say, an AI's answer to your question, and give it a single number score. That score represents how much a human would, prefer that response. They're absolutely crucial in reinforcement learning from human feedback, RLHF. And that whole process is what aims to make large language models, LLMs, helpful, harmless, and honest. So in essence, these models are where the human value rubber meets the road in AI development.
And for so long, these models have felt like a real mystery, haven't they? Something so critical, yet almost entirely hidden. But that picture is finally starting to change. We're seeing things like the reward bench leaderboard pop up, and that's helping. By publicly benchmarking and comparing different reward models, fostering more transparency, opening things up a bit. For this deep dive, our main source is a really groundbreaking new paper from researchers at the University of Oxford. They took a truly novel approach to dissecting these models.
And when we say novel, we mean they used a somewhat radical idea,
Okay.
exhaustive search. Instead of just looking at typical LLM outputs, which is what most folks do, these scientists scored every single token in the vocabulary of 10 different open source reward models.
Okay, hold on. Let's unpack that. When you say tokens, you're not just talking about whole words. You mean
Yeah.
everything, like bits of code, punctuation.
Exactly. Word fragments, emojis, code snippets, punctuation of the works. It's incredibly granular.
Wow. That's a much deeper level than I'd have guessed for defining values. And the way they tested them was clever, too. Simple questions, but value-packed ones.
Precisely. Things like what in one word is the greatest thing ever. And focusing on those single token responses was key. It's what made this huge, exhaustive analysis actually feasible from a computing standpoint. Think of it like getting this unique, unparalleled window into value interpretability inside these systems.
And what they saw through that window, it was pretty striking, right? Stark differences, even between models from the same developer.
Oh, definitely. Take the positive end of the scale. One model, RGEM2B, it really prioritized affective terms, words like love, felicity, even sonder.
Sonder. That's the one about realizing everyone has a complex life, yeah. And miraculous, too.
That's the one. But then another model, RL3B from the same developer, leaned much more individualistic. It favored words like freedom, opportunity, discovery. Very different feel.
Okay, but here's where it gets really interesting you mentioned. The negative end. The low-ranked tokens. Those findings sounded genuinely concerning. RGEM2B, the first one, gave low scores to awful things like rape, Hitler, murderers, but also slurs like faggot, Negroes.
Right. Things associated with human harm and profanity.
But then RL3B, the individualistic one, its lowest ranks were mostly like malformed code tokens and programming artifacts. Things like assert false.
Yeah, exactly. Malformed code. It's almost bizarre when you contrast them directly.
One model hates human horrors, the other hates bad code. The implications, though,
They're serious.
they really are. And the implication here is significant. What's truly unsettling isn't just that difference, but the disturbing patterns that kind of emerged across models. You see, beyond those distinct preferences, the researchers found something maybe even more insidious. Both models, despite their other differences, showed concerning behaviors with tokens related to minority identity groups, like blacks or homosexuals.
So systematic devaluation. It looks like it. And it likely stems from how these groups are disproportionately represented in the unsafe or rejected examples used during training. And the risk there is what the researchers call linguistic erasure, basically silencing or diminishing certain groups or experiences within the AI systems we all use, which is, concerning.
Wow. Okay, so beyond those specific, really striking examples, what about the bigger picture, the overall statistics? You mentioned they all showed a positive skew. Can you explain that a bit more?
Yeah, so imagine a graph. Most tokens get pretty low scores clustered down at the bottom, but then there's this long right tail, meaning a small number of tokens get substantially higher scores than everything else.
Right.
That's the positive skew.
Okay, got it. And despite that shared skew, there was still a lot of difference in which tokens got those high scores?
Absolutely. Substantial diversity in the rankings across the different models. Even though there were positive correlations, they weren't totally random. It really challenges this idea that you can just swap one reward model for another. The researchers found the original base model the reward model was built on, and its ranking on that reward bench leaderboard were big factors in how similar they were, which suggests these reward models actually inherit, quirky biases from the big language model they started from.
Yeah.
That's a pretty profound finding.
And it gets even more fascinating. You mentioned they found sensitivities that kind of eerily mirror human cognitive biases, like with sentiment.
That's right. With sentiment analysis, if you prompted them positively, like greatest thing ever, they consistently scored positive sentiment tokens higher.
Which sounds logical on the surface,
Yeah.
but there was more to it.
Yeah, the nuance was in the differential sensitivity. For those positive prompts, the models were actually more sensitive to find distinctions between positive words compared to negative ones. They were better at telling good from great.
Interesting. And then they flipped it with the prompt framing experiment, asking about the best versus the worst thing.
Exactly. What in one word is the best thing ever? Versus what in one word is the worst thing ever? And the best thing prompt just replicated that positive bias we saw, but for the worst thing, prompt, suddenly negative sentiment tokens got higher rewards, and the models became more sensitive to the differences between negative words.
So just like us, ask positively, we focus on the positive. Ask negatively, we focus on the negative.
It's remarkably similar to human behavior, yeah.
And that has really important implications for AI alignment, doesn't it? Because if your goal is stopping harmful outputs, the model needs to be sensitive to negative stuff.
Absolutely.
But the way they're often trained now, asking humans to pick the better of two options, might accidentally be pushing them towards positive tokens.
That's the concern, yeah. It might inadvertently bias them.
And you mentioned it's not a simple inverse. Best isn't just the opposite of worst for these models.
No, it's more complex. The distributions look more like a funnel. Lots of tokens are bad answers for both prompts. But then some are good for best, but bad for worst. Some are the opposite, and some, weirdly, are seen as okay responses for both.
Huh. Okay. And then there was this other effect, the mere exposure effect. That sounds intriguing.
It was quite surprising. They found that basically the more common a word is in English based on big text databases, the higher the reward model tended to score it. And this held true even when they controlled for the word sentiment. So it wasn't just that common words are often positive.
Wow. That really suggests leakage, like you said, from the base models, right?
It seems like it.
But hang on, if reward models are supposed to fix LLM biases, aren't they just amplifying this frequency bias instead?
That's a really good point. It's just common tokens might get scored higher than they maybe should.
Which could explain why we get those kind of bland, overly generic outputs so often from public LLMs. It's not just the LLM, the reward model might be nudging it that way.
Exactly. Like familiarity breeds high scores, almost.
Yeah. So the real acid test isn't just internal scores, it's how they compare to actual human preferences. And they use this ELO everything thing.
Right. ELO everything. It's this external crowdsourcing platform. People online basically rank things, concepts, people from Wikipedia. They just do pairwise comparisons.
Yeah.
Pick which of two things you prefer, and it generates an ELO rating, like in chess.
Clever. So they use that as a sort of ground truth for human values.
Kind of, yeah. They adapted their method, used a prompt like, what one single thing, person, or concept is the greatest ever, and compared the model's top-ranked tokens to the ELO everything rankings.
And the results, how well did they align?
Only moderately. The average correlation was about 0.29, so some agreement, but not huge. And again, lots of variation, substantial heterogeneity between the models themselves. They weren't all agreeing with humans, or even each other, really.
And there was the asymmetry again. They agreed more on the highly rated stuff.
Yeah, exactly. Stronger agreement with human rankings for things humans rated highly compared to things humans rated poorly. The example of the Holocaust was pretty stark, ranked worse by humans, obviously, but it was rated substantially higher by most models.
Which reinforces that earlier finding about being more sensitive to high-scoring tokens, less so to the really negative ones.
Does seem to corroborate that, yeah.
And they found specific areas of disagreement, too. Things models consistently got wrong compared to humans.
They did. Models tended to undervalue concepts about like nature and life, universe, gravity, breathing, also tech stuff like technology, computer.
Okay. And what did they overvalue?
Mostly affective qualia, so words describing subjective feelings or mental states. Things like unconditional love, imagination, hope.
Right. But the most striking ones were the undervaluations, sexual content, and identity groups.
Yes, that was particularly concerning. A systematic undervaluation of sexual content, terms like sex, human sexual activity.
Huh.
And, worryingly, the identity reference black people was also consistently undervalued by the models compared to the human ELO rankings.
Which brings us back to that really crucial challenge for alignment.
Exactly. Humans get context. We know a word can be fine in one situation and not another. But these models, maybe to be overly cautious about harmlessness, might just hedge against using certain terms altogether. And that, paradoxically, causes harm through this linguistic erasure or devaluation. It's a really tricky side effect.
So they couldn't check every possible sentence, obviously, but they used the technique GCG, greedy coordinate gradient,
Yeah,
to look at longer sequences.
that's right. Searching multi-token sequences exhaustively is just computationally impossible.
But GCG is an optimization method that let them efficiently find sequences that scored optimally high and optimally low, the best and worst sequences.
And did that reveal anything new? Different patterns than the single tokens? Some intriguing things, yeah. For instance, programming stuff, like code tokens with no real meaning, consistently scored low for both best and worst prompts. Made sense. Also, responses that basically said the question was subjective, like there's no objectively best thing ever, it's subjective. Those actually scored highly for both positive and negative prompts.
Maybe just avoiding taking a stand, avoiding negativity.
Possibly reflecting a kind of general avoidance of negative sentiment, yeah.
No.
And unfortunately, that linguistic erasure thing popped up again. The token Jews appear to the worst scoring sequences for both the greatest and worst prompts.
Oof.
On a perhaps lighter note, emojis showed up a lot in the best scoring sequences.
Really? Emojis?
Yeah. And interestingly, many of these optimal sequences found by the search weren't actually grammatical English, which highlights a key difference, right, between the raw reward model and the final language model that's been fine-tuned to produce fluent text.
Right. So, okay, let's try and wrap this up. Key takeaways from this deep dive. We've seen huge differences between reward models, even from the same creators. They're definitely not interchangeable. We've got this mere exposure effect, common words getting higher scores, maybe leading to those generic LLM answers.
Right.
The huge importance of prompt framing how you ask massively changes the model sensitivity.
Crucial point.
And maybe most worryingly, this systemic undervaluation of identity terms and sexual content, risking linguistic erasure, that feels pretty significant.
It really is. These findings underscore that reward models, despite their limits in the ongoing debates, are a really valuable lens. They help us understand how human values actually get encoded, or maybe misencoded, into AI. And more than anything, I think these results just scream for, more careful thought about what data and whose data we're using as the basis for human value in AI training.
It really makes you wonder, doesn't it? You said that they don't just treat positive as the inverse of negative, but operate in this, higher dimensional space.
Potentially, yeah. A multi-attribute space.
So what does that actually mean for designing AI that truly gets the complexity of human values? Beyond just helpful and harmless, how do we even start exploring that multidimensional value space? And what are the next steps there? Something for all of us to think about.